Hey guys, welcome to Leetcode Solutions. The Leetcode Solutions series is inspired by this amazing YouTuber Neetcode. Credits to him for inspiring me to create these videos. I will leave a link to his channel in the description below. Today we'll be looking into an easy level Leetcode problem called contains duplicate. First, we will look at the problem statement, then we'll work on a solution on whiteboard, and finally we will write the code in Python. So let's take a look at the problem to find out what it is. Okay, so the problem says given an integer array nums, return true if any value appears at least twice in the array and return false if every element is distinct. So we need to find out if any number in this list that is given to us in the input list appears more than once, and if it does, we return true. Otherwise, we return false. An important thing to notice here is that the elements in the input list do not appear in any fixed order. That is, neither ascending nor descending. It can be jumbled, and there can be any number of repetitions as well. If this was a sorted list, then it would have been much easier because we know that if a number appears more than once, it would be next to itself. So it will make it easier. But because it is jumbled, it becomes a little bit tricky. So let's look at um, one of the ways of solving this problem, which would be an intuitive brute force way of solving it. And although it's not optimal, but it is a solution. And first, let's look at that solution on whiteboard, and then we move on to the optimized solution. Okay, let's consider our list of elements 1, 2, 3, and 3. And actually, instead of 1, 2, 3, and 3, I'm just gonna have 1, 2, 3, 4, and then 3. So in our brute force approach, we go through every element in the list and compare it with every other element in the list. That is, we start at 1 and we check if 1 exists in anywhere in this list. So we have our first element and we check against every element to find if it appears again. And if it doesn't, then we move on to the next element, which is 2, and we repeat the same process of finding 2 again in the list for the remaining length of the list. And it goes on until we find an element, or we just go through all the elements to find no repetitions. Now this is an O of n square solution. How is it O of n square? So you have an outer loop the outer loop will run for the length of the list n, and then we have an inner loop which will run for the length n again, because we have to check if the number here is equal to the number here. So this, in the worst case, will also be of length n. So we have a nested loop resulting in an O of n square time complexity. Now there is a better way of finding a solution to this problem, which will take O of n time. And now we'll take a look at the optimal solution. And for this, we need a data structure called a hash set. Now, why do we need a hash set? Can we not have a list? Can we not have a map? Sure, we can. We can have a map, we can have a list. Um, but the problem with using a list is that it wouldn't really help in the time complexity, because I'll come to that once I'm done explaining this part. So we need a hash set, and why we need it, I'll explain it in a while, shortly. So consider this as a hash set of elements, and we have our nums 1, 2, 3, 4, and 3. In this approach, we take the first element 1 and we check if the number appears anywhere in the hash set. Initially, when the hash set is just empty, we can say that 1 doesn't appear, so we add 1 to the set. And then we move on to the next element, which is 2. And then we again check if 2 appears anywhere in the set. Since it doesn't, we add it to the hash set. And then we move on to the next element, which is 3. 3 also doesn't appear anywhere in the hash set, so we add 3 to it. And then we go to 4, we add 4 to the hash set again, because 4 doesn't exist in the set again. Now when we come to 3, we check if 3 exists in the hash set, and we see that it does exist. Hence, we return true. If there was no other element here, we would have gone through all these values, never to have found any duplicates, and finally we would have returned false. So that is an optimal solution, because we traverse through this list only once, and that is the end of it. So our time complexity is O of n. Now you must be wondering that, okay, but we are also trying to check if this number exists in the set. So let's say we have reached 4 and we want to check if 4 exists in the set. That could mean that it can take O of n time, because, well, it has to go through and check the whole length of the set. But that's the beauty of a set. A hash set stores its values using a hashing function. And with the hashing function in place, the set knows exactly where to look for to find a particular key. So if I am storing 4, the hashing function would have stored it in such a way that when I find 4, it will take me exactly to that place, which makes finding, or the get operation of a set, constant time. If we had used the list instead of a hash set, we could have achieved the same result, but it would have been O of n square again, because we would have added 1, 2, 3, and 4, and when we check for 3 again in a list, it takes linear time to search for an element in the list. It's an O of n operation in a list, but in a hash set it's O of 1, which is why we have used a hash set to store the elements as we see them in the list. So this makes our space complexity O of n and time complexity of O of n. Why is the space complexity O of n? In the worst case scenario, when there are no repetitions at all, we would have added every element of the list to the hash set, thereby having n elements in the hash set and n elements in the list. And this value is a function of the input list. As the input list increases, the set size will also increase. So that was the whiteboarding for this problem. O of n space-time complexity, and now we will proceed to the code. Let's see how the code for this would look like. And we start with initializing a num set. And then we traverse through the list for every number that appears in nums. If num is a part of nums set, then we return true. Otherwise, we just add nums to num to the num set. And finally, we exit the loop having found no duplicates, and we return false. And if I run the solution, it should be accepted, and there we go, it has been accepted. So this is a working solution and it works just fine. So that was the video, guys. I hope you liked it. Please do let me know in the comments if you have any suggestions, opinions, or complaints. I will leave a link to the HackMD and GIST pages for the detailed solution for this problem, and I will also leave a link to the Leetcode problem in the description of this video. Thank you, and you have a wonderful day.